Here we go. We proceed solving the questions. So we are still on bearings. I guess this is the first example. Okay. Alright, so in this video we are going to solve some questions that involves bearings. We start with the first one here. The question says we have two mountains here, R and S, which are located in Zambia. Now these mountains are such that R is on a bearing of 113 degrees from S, okay, and S is on a bearing of 295 degrees from R. So we want to illustrate the information above on the map. Alright, so let's say we have our solution here. Okay, so we have our solution there. Alright, so how we're going to do this? So the first thing is to get our protractor. Okay, I guess I did not get it. So we get our protractor and then we do the work. Okay, so let's rotate this one. Okay, oh no, I want it to rotate. Okay, let's make it rotate at 180 degrees. Okay, so let's put it here. Okay, so the bearing we want to draw here is 113. Obviously that one will be upward here, we can tell from the question. So you follow just those 3 steps. So the first thing, you draw your north pole, or rather your north line. Okay, so this is my north line, and then from this line I need to measure a bearing of 113 degrees. So remember, bearings, when measuring bearings, we measure using the outer range and in a clockwise direction, right? So here I'm starting from this point, so 0, 10, 20, 30, 40, this is 90 here, okay? This is 100, this is 110, 120. Now I need 113, so this is 110, so 113 is somewhere here. Okay, so 113 is here. This is 110, so 113 is passing in there. Okay, right, so that's my 113 degrees here. This is the bearing 113, right? So you need to indicate. Okay, let me just write it here, 113 degrees. Then we have another one which is 295 degrees, right? So we get another protractor, and that's 295 degrees. Okay, so we get that one and put it here. That's at 295 degrees. So we also get another one. Let's get another one here. So this one, okay, let's make it rotate at 180. Okay, why have I used 2? I've used 2 so that we can have a circular protractor. Look at the angle, the bearing we are measuring, it's 295, so it's above 180, right? That means we can't use a 180 protractor, we need an addition. So I've made it a circular protractor. That's the one you need to use, or you can improvise like the way I've done. Okay, so we know that from this point here, this is our starting point when counting. This is our north line, right? So we go clockwise. We want 295, this is 180 here, this is 270, 280, 290, so 295 is here, okay, somewhere there. So what do? You draw your 295 from the center, okay, so your 295 is passing at this point, okay, right? So you need also to show, so your 295 bearing is all the way around up to the path which is leading you to in fact, this is our R, right? We have our R and S. So this is our R, the point here is R, and this is S, okay? This point here is S, okay? So what do we do now? We just need to arrange, okay? So there should be like this, so that this is how we can show them on the map, the 2 points or the 2 positions. This is how they relate to each other. Hope you are able to see, okay, hope you are able to see here. So we can say that the bearing of here, we can say that let's have this one as our A, okay. So here we can say that the bearing of R, okay, R, now the bearing of this R from the bearing of this R from S, so it's a from S is what? Is 130. No, that's 295, okay, that's 295 degrees, okay. Why do we say this? It's 295 degrees. So look at, we are saying the bearing of R, this is R from S, so it means our starting point is at S. So we locate our north line, so from the north line here we go around to this point, and we've been given that this is 295. So that's why we are saying the bearing of R from S is 295. So this is not 5 but S, okay, yes. So my B, we can also establish that the bearing of S from, okay, so the bearing of S from R is 113 degrees, okay, right. So your starting point will always be where you are coming from, okay. If we say the bearing of R from S, it means we are starting at S going to R, okay. Yep. So that's how we do it. I think this is enough. Let's hope you are able to see how we draw bearings, and if we have 2 position of 2 points, rather 2 bearings, and then we want to relate them on the map to show which direction was the other position in relation to the other, okay. So this is how it works, okay. Now let's go to the second example, this one here. So under this one we have the first question, that is, given the 2 positions in the diagram below, that is P and Q, okay. So here we have our P and our Q there. Now in these points, calculate the bearing of A, that's, we are here, P from Q. So I want you to note something, it's P from Q, not Q from P. Our A is P from Q. So where are we? Our starting point is Q. So we are at Q. We are going to P. Okay? So we are coming from Q to P. So we are at Q now. Okay? So you need to identify this as your north. These are your north lines. So we are saying from the question, which is saying the bearing of P from Q, it means we are at Q. Q is our starting point. So you locate your north. Okay, this is my north. So this is where I'm starting from, this straight line here up. So this is the bearing is starting from this north and then going a clockwise direction. Am I going to end here? No, I need to find a path which is leading me to P. So this is the path and that's where I'm going to end. Okay, so this bearing is what I'm looking for. So how am I going to calculate this space? Well, there are two ways that you can use. The first one, we know that if you have a circle, okay, the complete thing here, we measured that its angle is a 360, isn't it? So if we have a complete circle, the bearing is 360, or rather the angle is 360 degrees. So out of 360, you've been given 60 degrees. How do you find the remaining? So there now you see what we're supposed to do, right? So we have 360 as the total for a circle, right? Now this 360 minus 60, and we are going to get nothing but 300 degrees. Alright, and it is already in 3 figures. So the other method we can use is, remember what we learned regarding the straight line. Okay, so a straight line, its angle was adding up to 180, right? So consider this one to be a straight line again. Let me just use this color. So consider this north pole here, the north line here. I hope you are able to see it. It's here. Okay, consider this one to be a straight line. And what did we say are the properties of a straight line at a point? So the whole of this from here up to here, it's 180, right? Now out of 180, you've been given 60 this side, from here up to there. That means the remaining part, this one, okay, from here up to here, it's 180 minus 60, which is going to give you 120 degrees. Okay, 120 degrees. And this one here, it is also 180, right? That is from here round up to this line, this is 180. Okay, right? So to find the bearing which you want, that is from this point, go round up to this path which is leading you to P, it's same as this 180 you have, okay, this 180 you have plus 120. Okay, and when you use these properties, you are going to get 300 again. Okay, so whichever way which is easy for you, you can solve these questions using these two methods I've showed you. Okay, and the properties on of parallel lines and a transversal line, rather two parallel lines cut by a transversal line. What are the properties of the angles formed? You can use them in your calculation. So straight away we go to question B. So question B, the question is calculate the bearing of Q from P now. So this time we are coming to Q from P. So from P we are coming from P. So we are at P. P is our initial point, rather this is the starting point. So you locate your north. Okay, hope you can see how I'm locating my north upward at this point P. So from this you need to draw clockwise and find your path which is leading you to P, I mean to Q, okay, which is leading you to Q, because we are moving from P to Q. Okay, so my starting point is P. I'm coming from P to Q. So from P I locate my north. From north I move in circular form while moving in a clockwise direction until I find this path leading me to Q. And so this is the bearing. Right? Now again, if you use the properties of angles formed when two parallel lines are cut by a transversal line, you realize that the angle which you have here, okay, which is 120, and this one, they are alternate interior angles. So this is nothing but 120. So the bearing here is also 120 degrees. Why? Because these two angles are alternate interior angles. Okay, so you need to write the reason there. They are alternate. Okay, alternate interior angles. Okay, this reason you need to give. The other method you can use here is to remember that when two angles are on the same side of a transversal line and between two parallel lines, these are they are supplementary angles, right? They are supplementary angles, so they add up to 180, right? So since we have a 60 here, right, to find this one here, the opposite one, this one on the same side of a transversal, we subtract 180, we subtract 160 from 180, we subtract 60 degree, from 180, subtract this angle from 180 and get 120 as well. So it will still be the same. All you need is to understand the first class I gave you on angles and the angles on parallel lines. Then these calculations will be very easy to you. Alright, let's proceed and go to question 3. It's saying the question is calculate the bear. So we have 2 points M and N. Okay, so let this be our M and this is our N, and we need the bearing of M from N. Okay, this is M from N here. Okay, and then this one will be N. Okay, the bearing of N from M. Okay, so now we're going to calculate the bearing of M from N. So it means we are at N. N is our starting point, right? So we locate our north. So this is our north. So hope by now you can see that the north line is a very important concept that you need to know and understand and know how to use it. Okay, so from north we go around. Remember, from north up to here, this is our 180, just like in the previous example. Okay, and then we need to find the root which is leading us to M. So this M will go straight and find it here. So one thing you need to notice is that our transversal line is cutting the two parallel lines at a 90 degrees angle here. Okay, what does that tell you? If this is meeting the parallel line at 90, this parallel line to this one at 90, it means even here at the base is 90 degrees and this side we have 180. So since the bearing we need is starting from this point going around up to this point, it means to find the bearing of M from N, which is our A, it's same as adding 180 degrees there, okay, plus 90, which will give us nothing but a 270 degrees as the bearing, right? And the other method you can use likewise is realizing that angles surrounding you at the point where you are adds up to 360. Okay, so if 360 you subtract what you have, that is 90, you are going again to get a 270 degrees as the bearing you are looking for. That is the bearing of M from N. Okay, alright. make sure you ask if you miss a point somewhere. Okay, use the zoom button. There's a feature there for raising the hand. Just click on it. I'll be able to see that you've raised your hand, and I'll be able to attend to you. Okay, so we proceed. B, we need the bearing of N from M. Okay, so this time we are coming from M going to N. Okay, so remember, you locate your North Pole. So am I going to move like this, going to M like this until I reach here? No, we don't do that. We move in a clockwise direction from north. Okay, so the only way I can move is from here up to this path leading me to M from leading me to N from M. Okay, so this is my bearing, which you can see without even calculating that this is 90 degrees, right? Yes, this is 90 degrees. But if you like solving and you want to calculate, you know that this is 90 degrees, right? And these two angles, they are on the same side of a transversal line and between two parallel lines, right? So you subtract 90 from 180 to find the other one, this one, and that will give you nothing but 90. Okay, so you can use that one if you want. Let's now finish up with our last question. So in this one we have two points, that is x and y. So from x and y we need the bearing of x from y. So we are coming from y going to x. Again, you realize that after locating your north line, okay, which is this one here, your bearing will move from this line going around until you find your path leading you to x. So that means to find your A, you just need to add, because from here up to this point, this is your 180, right, plus 85. Same manipulation here, and you're going to get, well, this is a degree, so we are going to have 180 degrees, right, plus 85 degrees, okay, and this is going to give you 265. So just try to confirm if this is if it's giving you 265. I said 180 plus 85. I guess it should give me 265 there. Wow, just confirm to be sure. So that's our answer. But if you you also want to solve here, you can still make the work a bit hard for you. You know that the whole of this angle from here up to here, it's 180, right? So 180, you've been given 75. What are you going to get? You're going to remain with 95 if you subtract this from 180, which is the total angle of a straight line. So that is 95. If you get 95 there, then you can subtract 360, right, degrees minus your 95. You found 95, which is just an angle here, and you are going to get 265 even here. And one thing that we forgot on top is, remember, these are bearings and not angles, right? So finding a bearing of 90 and writing it this form, this means an angle and not a bearing. So to be specific that this is a bearing, we add a 0 in front, and that now shows us that this is a bearing. Okay, we proceed with B. So B, we need the bearing of y from x. Okay, y from x. So we need y from x. So we are coming from x going to y. So we locate our north line. Okay, so this is our north there, and so our bearing is starting clockwise up to the path which is leading me to y. So this is the bearing I'm looking for. Okay, now here is those properties you need to use. Remember that this angle here, okay, this angle here, which is also this one here, which we've been given as at 85, and this one here, they are alternate interior angles, right? So the bearing we are looking for is nothing but 85 as well, 85 degrees. But remember, this is not an angle but a bearing, so you add a 0 in front to make a bearing, to be specific. The other way you can use is to remember that these two angles, right? These two angles, this one and this one, they're on the same side of a transversal line, right? This one here and this one, they're on the same side of a transversal line, and between two parallel lines. That makes them supplementary. So what are you going to do? The other method you can use is to use the total, because they add up to 180, right? So you subtract 95 from 180, okay, and you get 85 again. Okay, I mean, that's 85. This 0 are supposed to be added in front, okay, okay, and that's 85 degrees there, right? Wow, so this is how we use those properties to answer bearing questions. Hope you've understood. Make sure if you have any question, don't forget to inbox me, and I'll be able to produce another video to make sure I explain where I do not understand. So thank you so much for watching. Please subscribe to our YouTube video. Don't forget to press that button below and subscribe to our YouTube videos. Bye bye. See you in the next video.